The next quadrilateral we'll talk about is a trapezoid. Trapezoid is not a subshape of a parallelogram. So this is the first one that we've dealt with that is not a type of parallelogram. The thing that sets trapezoid apart from parallelogram is that it only has one set of opposite sides that are parallel. So one set of opposite sides are parallel. Okay, there's different parts of a trapezoid. We've got bases. Okay, the bases are the parallel sides. So when you see bases, it doesn't mean it has to be on the bottom. So I could twist my trapezoid around and it would still be the parallel ones that are, okay, so if I twist it this way, these are the bases, the left and right, because those are the ones that are parallel. Okay, so they're not always going to be on the top and bottom. So this is a base 1, base 2. There's base angles, okay, and there's two sets of base angles. So these angles together down here, since they're sitting on base 2 together, they're base angles together. These angles up here are another set of base angles because together they're on base 1. The legs are the non-parallel sides. Okay, so the bases are the parallel sides. Legs are the non-parallel sides. The base angles are consecutive angles on the same base. So let's fill in our, well, let's do one more and then we'll fill in our front here. An isosceles trapezoid is a trapezoid, but it's got congruent legs. Okay, so it's a trapezoid with congruent legs. Okay, so an isosceles trapezoid is a lot like an isosceles triangle. So if you remember an isosceles triangle, so here's our trapezoid. In a triangle, we said that if the opposite sides, if two sides were congruent, then the opposite angles were congruent, and that's true for isosceles trapezoid. So our base angles theorem applies. So if I have the legs that are congruent, that means both sets of base angles are going to be congruent. And this goes the other way too. So if I have a set of congruent base angles, that gives me, okay, that gives me the other set, and it gives me the legs. Okay, so if I start with just one set of base angles that are congruent, I get the other set of base angles, and I get the legs congruent. Okay, so let's fill in the front here with our trapezoid. Our trapezoid's going to take this spot here. Oops. So trapezoid, the thing that brings us over here is one set of parallel opposite sides. The thing that'll bring us down to an isosceles trapezoid. Okay, the definition is that you have congruent legs. Okay, or you could have congruent set of base angles. And there's one other way, and that other way is if the diagonals are congruent. Okay. So I'll put that on here. So trapezoid with congruent legs and congruent diagonals and congruent base angles. Another thing that comes back from triangles is the mid-segment. Mid-segment is a segment that connects the midpoints of the legs. Okay, so if I've got midpoints of the legs and I connect those to the segment, I get a mid-segment. And all the same properties that were true from a triangle are also true for a trapezoid. So it's going to be parallel to both bases. It's also going to be half, okay, but it's not half of just one side, it's half of base 1 plus base 2. So half the sum of the bases. Okay, so here's our trapezoid example we'll go through. I'll find all the missing measurements. Since these lines are parallel, that means that these are going to be consecutive interior angles. Okay, this one and this one. So that's still, I guess we could put that as a property of trapezoids. Consecutive non-base angles are supplementary. So like red and blue would add up to 180 together. So if this is 110, I know this is going to be 70, because they have to make 180. Since these are parallel, this is 70, so this would also be 70. Okay, so this transverse, so those are corresponding. This would be corresponding to the 110. Since this is 70, I know this is going to be 110. This would be corresponding to the 70. This would correspond to the 110. Since these are congruent, really I know that I now have an isosceles trapezoid because I've found out that I've got congruent base angles. So I could just change this marking to represent that. The length of my mid-segment is going to be half the sum of my bases. So if I add my bases together, 12 plus 20 is 32. Half of that is 16. So this segment is 16. So that's all the stuff you can do with properties of trapezoids. And so I've split 6.5 up into two parts in your assignment section. This covers the first part, which is all about trapezoids. So all the problems in the first part of trapezoids. The next part is kites, and I'll make that into a separate presentation.